Welcome to this next FP1 tutorial. Now what I've done here on the board is I've put a little table on. So for each angle of rotation, okay, this is a rotation for matrices, okay, this is the transformation matrix for each rotation, okay. So obviously you can work out that quite clearly it's going to be a anti-clockwise rotation, because if you look at the transformation matrix which is shown for each angle, okay, you can quite clearly see, well, the first component is made up of the end I component, okay, which it was initially 1, 0, and to go to 0, 1 must have gone through anti-clockwise by 90 degrees, okay. So that's just analysing the first column of the 90-degree transformation matrix there. Okay, so obviously, you know, standard pattern for transformation matrices, and just to refresh your memory, a rotation, when you work out the coordinates of the new shape, okay, you do the transformation matrix times the original matrix, or the original points of the previous shape, okay. It sounded really intelligent, this, yes. Whatever. Okay, what am I going about? Well, in this video we're going to be looking at combining transformations. Now, it's a very, very simple process, okay. Basically, you might get something that says rotate the shape by 90 degrees followed by a rotation of 180 degrees. In other words, you do the rotation of 180 degrees and the rotation of 90 degrees. So you do a rotation of 90 degrees followed by a rotation of 180 degrees, okay? So the first rotate, so it's almost like reading, instead of, you know, normally read left to right, it's reading right to left, okay? So you do the rotation of 90, then 180, okay? So basically you do a back to front list of, in order of the rotations you're being told, okay? So it's rotation of 180 followed by 90. So if we put another number there, say 360, this would say the rotation of 360 rotation of 360 followed by 90 followed by 180. Okay, so it's a back to front way of saying it. Okay, so just having 180 then 90 says a rotation of 90 followed by a rotation of 180. Okay, so if we put R360, just go that again, it'd be a rotation of 360 followed by 90 followed by 180. Okay, so hopefully, as I said, that kind of, I might have messed my wording up there, but that's the way it should be. Okay, so anyway, ignore the 360. You should quite clearly see as well the 360 rotation. We can also say that is an identity matrix. Okay, because obviously if you wrote something, rotate something through 360 degrees, you're going to get back to where it was. You're going to essentially times it by 1, and you times it by 1 by times it by the identity matrix. Okay, so that's why the 360 degree matrix is as it is. Okay, so basically you do these two transformation matrices times each other. So 181, which is minus 1, 0, 0, minus 1, times the rotation of 90 degree matrix, which is 0, 1, minus 1, 0. And if you were to do this out, okay, so you do column 1 times row 1, column 1 times row 2, column 2 times row 2, column 2 times row 1, column 2 times row 2, okay? What you'd end up with, by multiplying it out as you would do any matrix times in the matrix, okay, what you would get is 0, minus 1, 1, 0. The reason I did that so quickly, because I'm a genius, but anyway, it's the rotation matrix of 270 degrees, quite clearly, because if you rotate something 90 and then 180, you're rotating it from the start, previously, what you originally had, by 270 degrees. Now, you don't need to be an expert to work that out. But the reason that helps us, quite clearly, you could do that in your head anyway. You don't need, you know, just a stupid little bit of extra maths to get in your way. You're intelligent people. Well, intelligent enough to listen to me, that's questionable. But anyway, why am I telling you this? Well, obviously it's a topic, and it's another video I have to do to put online to show I'm going through the syllabus, obviously, to show myself. But in some cases, it might not be that easy. Obviously, we can quite clearly do it just by adding angles together that we're rotating through. Okay, But obviously, by the way, if it asks you to rotate by 90 clockwise and then rotate by 180 anti-clockwise, quite clearly what you've done there is just rotated it clockwise by 90 degrees, okay? Does that make sense? Right, I think that's alright. I don't know, something like that. You do, because obviously if you do the negative of each version of this, so if you, that's the rotation for clockwise, anti-clockwise of 90 degrees. If you wanted a transformation matrix of 90 degrees clockwise, you would do -1 times all that answer, instead of it would be 0, -1, 1, 0. Okay? Or you could just come up with that by working it out, like we've worked out each one of these. As I said, please do check out that transformation matrix video if that doesn't make sense, but hopefully it should. Okay, so anyway, going on to this next little bit. So the reason why I'm doing this is the harder rotations and reflections, well, more reflections actually, that we did. You can't really do a well, can you? So I don't think you'd be asked to do enlargement, two enlargements, because really that's not a transformation you can combine. You can't enlarge one shape by 3 and then enlarge by a factor of 2 of that one. You just break it down individually for that. Okay, so what I mean by that is, if you were asked to, so this, what I'm going to do now actually is lie down, go to bed, but do some maths in the meantime. So transformations, okay, so combining transformations, you can only, in this sense, I'm only going to be going through, well, I've gone through obviously the angles one, in terms of rotating it through an angle. I'm going to be looking at reflexing it now, combining reflections in the y-axis and then in the x-axis, or in the line y equals x, or in the line y equals negative x, okay? So please do check out that video, because there is transformation matrix associated with that, which I will be picking up, but I'll try and give a bit of background to it. Anyway, what I was trying to say, but I tried to confuse myself, is you can't really combine an enlargement with another enlargement in the way we have done here. You know, we did rotation of 90 followed by 180. We did that 180 times R90. Okay, you can't really do reflection, enlargement scale factor 3 and enlargement scale factor 2 in the same way, because to work out enlargement we had to actually you would work out the enlargement of a scale factor 3, work out the answer, and then do that in the same. I'm not making much sense. So you get an answer, okay, you work out the transformation matrix for an enlargement of scale factor 2, say, and then you work out your answer for that, okay, like you would do any other previous example we've gone through, and then when you get a matrices, your answer, you times that by a scale factor 3 or whatever it might be, okay? Hopefully that kind of makes some sense. Might not do, but whatever. Okay, so that's why I'm not really going to go through that, but as I say, you can do that by yourself, and any questions please do let me know, but hopefully it all makes some kind of sense. Okay, so just going to pop a few rotations now in terms of more transformation matrices. But as I say, I'm not going to go through any angles, so you can really kind of cross it off now if you want. Excuse me. I'm going to throw it. Sorry, just a sec. So it's a reflection in the x-axis, so label this Rx, is equal to 1, 0, 0, minus 1. And a reflection in the y-axis has these are transformation matrices of either one, is -1, 0, 0, 1. Okay, so they're the two transformation matrices. That's the transformation matrix for reflection in the x-axis, and the other one is a transformation matrix for reflection in the y, Rx. Reflection in the x-axis, Ry. Reflection in the y-axis. Okay, so you can correspond them quite clearly. And if you would do the same principle like we did before, okay, if you were going to do a reflection in the x-axis followed by a reflection in the y-axis, okay, it'd be Ry times Rx, okay, which you would just do -1, 0, 0, 1 matrix times 1, 0, 0, minus 1. Okay, and obviously you would work that out by column 1 times row 1 and column 1 times row 2. So column 1 times row 1 would be 1 times minus 1, which would be minus 1, and 0 plus 0 times 0, which is 0, which is that means you've got quite clearly minus 1. And in column 1 times row 2, so it's 1 times 0 plus 0 times 1, which is 0. And in column 2 is column 2 times row 1, so it's 0 times minus 1, and minus 1 times 0, which is 0. And then minus 1, then it's column 2 times row 2, okay, so it's 0 times 0, and then minus 1 times 1, which is minus 1, okay. So your transformation matrix for reflection in the x-axis followed by reflection in the y-axis is minus 1, 0, 0, minus 1, which is the reflection rotation of 180 degrees. The transformation matrix is exactly the same. Okay, so you follow the same principle of transformation matrix times the matrix, and we'll give you the new answer for that matrix transformed through whatever you want. Okay, so that's your key idea there. Alright, so that's kind of the end of this video. So I'm not going through any examples because it is really quite simple. And the only kind of complicated bit of multiplying matrices together I've done in a separate video. And personally, I didn't want to waste too much of your life and my life doing this. I'm sure we've got all better things to do. So you can go ahead and do them better things, unless it's like murdering someone, then I'd advise leaving about 10 minutes and notifying a few people of your intentions, but maybe that's why I'm not the world's greatest undercover murderer, or am I? You don't know. Anyway, so thanks for watching, and hopefully you're not too scared. I'm probably not a murderer, I just put it out there. See if you're actually paying attention. Anyway, so thanks for watching, and we'll see you in the next video. By the way, just for records, please, I'm not a murderer.